We're going to look at some harder examples of solving for all solutions of trig functions. So we're not going to be able to just isolate the trig function from the beginning by combining like terms, and we're not going to be able to factor either. We're going to have to try something else. In this first example, we have sine of x equals cosine of x. Let's try dividing both sides by cosine of x. Sine over cosine is tangent, and cosine divided by cosine is just 1. Now we have tangent of x equals 1, which is something that we can solve. From the beginning, if we wanted to divide by sine of x, if you're wondering if we could have done that also, we could have. Sine divided by sine is 1. Cosine over sine is cotangent. So this would have been fine too. It just makes this next step a little harder because now you're solving for something that has a cotangent in it instead of a tangent. Let's work from this problem. We're finding an angle where y over x is 1. Pi over 4 and 5 pi over 4. And remember, plus 2 pi n. Or a more efficient answer would be pi over 4 plus pi n. This next one looks like one that we could try to factor, but we have two different trig functions. So let's try to substitute the cosine squared. The Pythagorean identities have sines and cosines that are squared, so we know that sine squared x plus cosine squared x equals 1. We want to try to get a cosine squared x by itself so that we can substitute something into the problem. So we can subtract sine squared x. Now it matches with what we have in the problem, so we can substitute the 1 minus sine squared x in for cosine squared x. Now we still have plus sine x plus 1, but we have all signs in the problem now, so it's going to be easier to solve. I'm going to write it in order of highest exponent. Negative sine squared x plus sine x. We have positive 1 plus 1, so that's plus 2. And I'm going to divide both sides by negative 1 to make this a value of positive 1. And now we can factor this. This problem is similar to x squared minus x minus 2, but instead of x's, we have sine of x's. And if it helps you to see that more, if you wanted to write the sine squared x as a sine x squared, x squared minus x minus 2 factors as x minus 2 x plus 1. So this one's going to factor as sine x minus 2 and sine x plus 1. And we can set both equal to 0. Sine x equals 2, but there's no angle that gives a y value of 2. And sine x equals negative 1. That's 3 pi over 2 plus 2 pi n for all solutions.